Section 4.4a is about equations as relations. If you remember from previous sections, we learned that a relation is a set of ordered pairs. Now, since ordered pairs have an x and a y value, it makes sense that if you have an equation with two variables, that's an equation that contains two unknowns. Well, if you have an equation like that, that means your answers will contain two numbers that go in for those variables, therefore your answers will be relations. The solution of an equation that has two variables is the ordered pair that results in a true statement. And so we're going to look at some ways that we can find solutions for equations that have two variables. Well, here's our equation that we're going to use, y equals 2x plus 3, and we want to find the solution set, which means we want to find which of these ordered pairs make it true. Now remember that in an ordered pair, the first number is the x value, so all of these numbers in the front of the ordered pair represent x's, and all of the numbers in the back represent y values. To find if one of those is a solution, what you do is you take this first ordered pair and you substitute it in for the y and the x. So we will plug -1 in for the y, and we will plug -2 in for the x. Whoops, that should not be a comma. And now we're going to see if that's a true statement or not. Well, 2 times -2 is -4, and -4 plus 3 is -1, and -1 does equal -1, so that's true. That means that this ordered pair is a solution. Now, we can't just stop there, because when you're talking about equations with two variables, you have to try every single ordered pair to see if they work. So I'll plug 3 in for the y, plug -1 in for the x, and 2 times -1 is -2, and -2 plus 3 is a +1. +1 does not equal 3, so that is false. So we can say that that ordered pair will not work. Cross it off the list. And we have two more to try. Plug a 4 in for the y and a 0 in for the x. 2 times 0 is 0, and 0 plus 3 is 3. That is a false statement. So that ordered pair does not work. And the last one to try, 9 goes in for the y, 3 goes in for the x. 2 times 3 is 6, plus 3 is 9, and 9 does equal 9. So that makes it true, so that one is a solution. The way we write the solution set is we use squiggly brackets, and we list both ordered pairs. So -2, -1 works, and 3, 9 also works. Now this solution here is also known as a relation. We'll go back to the heading here because it's a set of ordered pairs. And so my solutions, when you have two variables in an equation, the solutions are relations. Here we're asked to find a solution set given a replacement set. Here's my equation, y equals 3x plus 4, and I want to find out which of these ordered pairs work. So I'm going to start by plugging them in. So y is the second number, so I'll plug a 1 in for the y, and then a -1 in for the x, and see if it's true. So 1 equals -3 plus 4, which means 1 equals 1. That's a true statement, so this one's good. Now 10 and 2, 10 for the y, 2 for the x. 3 times 2 is 6, and 6 plus 4 is indeed 10. 6 plus 4 is 10, so that's true. So this one works. Now 3 and 12, 12 for the y, 3 for the x. 3 times 3 is 9, 9 plus 4, 13. And that's false. So this one we can cross off. And the last one, 7 and 1, 1 for the y, 7 for the x. 21 plus 4, 1 does not equal 25, that's false. So that one goes away. Our solution set then is written as a set of ordered pairs, or written as a relation. Here's another example of finding a solution giving a replacement set for an equation with two variables. But if you notice, this one's different than the previous two, is that the y is not isolated. And in this case, to find a solution when you have an ordered pair, it's really not necessary to isolate the y. You just plug in the x and y and see if it works. Feel free to pause the video and try this one for yourself. I'm gonna jump right to the solution here and save some time. Here I've done the work. I plugged in -7 for x, -3 for y, and I got a true statement out of that. Down here I plugged in a 7 for the x, a 3 for the y, and I got a false statement there. So that one goes away. 2, 1, 2 for x, 1 for y, that was false. And -2 for x, -1 for y, that was a true statement. So my solution here, -7, -3, and -2, -1. This paragraph represents an extension of this relation idea. We've already talked about how an equation with two variables forms a relation. But I want to extend that to something else that we've learned in the past. Because ordered pairs involve an x and a y, that means the x value represents what we've called in the past to be the domain. And the y value represents what we've called in the past to be the range. All of the y values are the range, all of the x values are the domain. Now, why is that important? Here you see an example that says solve an equation if you're given the domain. Now, one thing that might confuse you here is this use of a and b. If you don't like that, go ahead and change the letters to x and y. It really doesn't matter what the letters are, as long as they're alphabetical. So we'll call the a the x values and the b the y values. So if it helps you to do this, go ahead and do that. But because we're given the domain, that means all of these values are x values. They are all domain values, which means to solve them, I'd have to find out what the y value is that goes with each one of them and then create those ordered pairs. So we're going to do that. We'll start by plugging in these x values. So we'll start with y equals -3 plus 5, and -3 plus 5 is 2. So when we plugged an x value in of -3, we got a y value of 2. That creates an ordered pair of -3, 2. That's solving an equation when you're given one of the values. Let's do this again for the next one, -1. So y equals, we'll plug -1 in, plus 5, which means y equals 4. When I plugged in a -1x, I got a 4 of a y. Now again, I'm using the words x and y. This started out being a's and b's. Try not to get confused by that. Next one is a 0, so y equals, plug a 0 in for the x value, plus 5. 0 plus 5 is 5. So when I plugged a 0 for x, I got a 5 for y. Next one is a 2, so y equals 2 plus 5. 2 plus 5 is 7, which means y equals a 7. When I plug a 2 in for x, I get a y of a 7. And the last one is 4. Y equals 4 plus 5. Y equals 9. So when I plugged in a 4, I got a 9. That's how you solve a two-variable equation when you're given either the domain or the range. So to write the solution, we're going to list all of our ordered pairs using squiggly brackets to show it's a relation or a set. Here's another example of solving an equation with two variables, and we're given the domain, which means we're given all the x values. That's what the domain is. So I'm going to plug those x values in and find out what the y values are. Now look at this equation. Since the x and y are on the same side, it might make this a little difficult. So I find it easier to isolate the value that we're looking for. So I'm going to isolate the y. We'll do that by subtracting 2x from both sides. So 2y equals, you could write this as 12 minus 2x or -2x plus 12. In this case, it doesn't matter. And now we'll divide everything by 2. Cancel the 2's here. 12 divided by 2 is 6, and 2 divided by 2 is 1. So we end up with a new equation of y equals 6 minus x. Now it's that equation that I'm going to plug all these values in for. So that's my solution. One last thing to note is both of my examples had the domain provided. You could also provide the range, the y values, and you'd have to plug them in for y and find out what the x's are. You could do that also, and it would be done exactly the same way except the other letter.